So here we are, we're focused on the study of data structures. The question is, why study data structures? Well, gosh, the world runs on data, enormous amount of data collected every day, in fact, every second. Everything is sending data now. It could be your automobile sending data, all the airplanes, the trains, all the devices that you use, the device there in your pocket, your mobile phone, it's sending data. Everybody's sending data. Cameras are grabbing data. Microphones are grabbing data. So all this data, we need to learn how to write efficient algorithms. And very important point, the data and the algorithm are closely aligned. Super important point. Data and algorithm are closely aligned. In fact, Linux, I said Linux, it's actually Linus Torvalds. That should be Linus, but I misspelled it because he's the fellow who designed and wrote the initial part of Linux. Also, he did Git, the source control system. But a good quote from him is, bad programmers worry about the code. Good programmers worry about the data structures and their relationships. And that's a super important point. You're going to still have your code, but you want to know about those data structures and their relationships and how your code should manipulate the data and the relationship. So data structures, here we are. The goal is to explore many different types of common data structures. Now, as you can imagine, there's all kinds of data structures, but there's some that you come into all the time, and here's the list. Arrays, stacks, queues, linked lists, binary trees, and heaps. We're going to cover not only the data structures, but we're going to also cover algorithms that relate to using those data structures. For example, recursion, sorting, and searching. As you can imagine, if you're doing recursion or sorting or searching, the way you do it could be directly impacted by your data structure. All right, let's say a few comments about each one of these data structures. Let's begin with the array. I've given the Wikipedia site so you can read some more information about an array. I'm sure you've used an array in your other courses. It's a collection of elements, each identified by an index. And so I give a Java example here. We have an integer array of nums, of which we have 3 items, 10, 20, and 30. The thing about array is very efficient, both in time and in space. That is, you can read and write any value in constant time. That is, I could get from the first value to the last value, the middle value, as long as I have that index, the time to get to it is the same. And also the space taken is a constant. So you know right up front how much space it's going to take. And probably a third one I should have put on there is arrays are native part of most languages, including Java, right? Just you have an array built in by default. Okay, next on our list is a stack. And I got to tell you, looking at this stack of plates reminds me of my job. I had just graduated from high school, had my high school degree. I was looking for a job, and there was a barbecue restaurant there where I lived in Columbia, South Carolina, actually, there on the East Coast, which is where my accent is from. And I said, I can be a manager of a barbecue place. I'll do that. So I went and they interviewed me, and the owner said, I'll hire you. But by the way, I start all my managers by washing dishes. So I spent the next month washing dishes. And that stack of plates looks pretty much like after I had washed the dishes and had to take them to where they were served to the people. Anyway, a stack is a abstract data type, and it's just got 2 operations. You push and pop. So as I was washing the dishes, I would push a new dish on top, and then when they were serving them out, they would pop it off and put the food on the plate and take it to the person. So this is also called a LIFO, last in, first out. So right, the last plate that you put on the stack is the first to get out. And here's a diagram I got from Wikipedia. It shows doing a push, 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 push. So notice I'm washing the plates and I'm pushing the new clean plates up on top. And then they start serving food. So they do pop, 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 pop. So So my word of advice, if you go apply for a manager job at a restaurant, be prepared. They may want you to wash dishes first. And if so, think about the stack. Okay, another related to the hardware stack. You hear the word stack as we're doing it with a data structure, but here I wanted to make sure you know that the stack is used in the computer itself. All computers use a stack. It's actually how the computer, when it makes a function call, it pushes information on the stack. And so it's a fundamental way, the way the computer works. Every time you make a call to a function, it pushes information on the stack. If you need to allocate data inside your function or inside your method, it comes from the stack. And so I just want you to be aware that in the world of computing, stack has two meanings. It's the hardware stack in the computer, and also what we're focused on is the stack as a data structure. Okay, we've got another one, a queue. This is a collection of items maintained in sequence and can be modified by adding to the back or removing from the front. Wow, think about queues all the time. Another term of it is first in, first out, right? The first in, first out. And we've all experienced this on a regular basis. If you go into a bank, every bank I've been into always has a bank teller where you have to stand in a queue, and everybody stands in a single line, and the next available bank teller will let you essentially be DQ'd. You walk into the post office, same thing. Imagine you walk in, you join the queue at the end by doing this in-queue process. And then when there's an available post office clerk, you are then DQ'd from the queue. Probably my favorite is Fry's Electronics, right? You go to Fry's Electronics, and Fry's has always had a queue, a single queue to serve people. And if you're into fast food, Wendy's fast food is a good example. All right, next on our list is the linked list. And the linked list, again, I'll give you the Wikipedia site if you want to read a little bit about that. It's a linear collection of data elements whose order is not given by their physical placement. And so linked lists are used quite often when you want to rapidly insert and remove items from a data structure. In fact, you can see there's two major ones. Up at the top is the single linked list. So you can see the data always has a pointer to it that's pointing somewhere else or a reference to somewhere else. And so we see 12 is reference to 99, is reference to 37. The nice thing about the linked list is you can remove items from the linked list and simply change those links, and you don't have to physically move things around. The doubly linked list is another popular data structure. Notice you can go in it. The double means you can go both forward and backwards. Also notice both of these lists have a termination. In other words, eventually you get to the end of the list because there's nothing else to point to, so you're at the end of the list at that point. We have a whole chapter where we cover in great detail linked list. Here's another one, the binary tree. Again, give you a Wikipedia link. A binary tree, each node has at most 2 children. In fact, that's where the word binary comes from. So you can see a picture here again from Wikipedia. We see the binary tree. In this case, it has a size of 9, has a height of 3, has a root node whose value is 2, and the above tree is unbalanced and not sorted. Now don't worry about all those details because, as you can guess, we have a chapter just on binary trees coming up later in the course. For now, the main thing to know is that a binary tree has nodes of at most 2 children. And so which is why it gets its name. You can almost guess based on its name. So much more detail to come on that. And as you can imagine, this is also a data structure used quite often. All right, next on the list is the heap data structure. A heap is another name to recognize that it's used 2 different ways in computing. First, there's the low-level memory heap. In fact, if you remember when you wrote C code, you may have done a malloc or a cmalloc. When you allocate memory at the runtime, you're actually allocating it from something called the heap, which is a low-level memory structure. That's not what we're talking about here. Instead, we're talking about the heap as a data structure. And this is a specialized tree-based data structure. We'll cover much more in a chapter when we come to talking about the different tree structures. But for now, again, the important point to know is that the heap, that term is used two different ways in the world of software. There's the low level, and then there's this heap data structure, which you will cover later in the course. All right, and with that ends this first part. Go to the next video and see the next part of the chapter. I'm Norman McIntyre. Thanks for watching.